Good morning, students. Today we are going to discuss about distance between two parallel lines. So first we will derive a formula for distance between two parallel lines in vector form, and then we will solve some question on it. So let's do it. Let us consider two parallel lines. Say the first line is vector r is equal to vector a1 plus lambda times of vector b, and suppose the line L2 is vector r is equal to vector a2 plus mu times of vector b. Here we can see that vector b is same in both the lines. Therefore we can say that line L1 is parallel to L2. ठीक है, क्योंकि लैम्डा के साथ में यहाँ पे भी वेक्टर बी है लाइन L1 में, और लाइन L2 में म्यू के साथ भी वेक्टर क्या है, बी है. तो क्योंकि यहाँ पे वेक्टर सेम है, इट मीन्स L1 will be parallel to L2. Let us draw these two lines. Say these are our two lines L1 and L2. Line L1 is passing through a point whose position vector is A1. So let this is point S, whose position vector is A1. And let the point through which line L2 is passing is point T, whose position vector is vector A2. Then if we join ST, then vector ST is given by vector A2 minus vector A1. Clear? And both these lines L1 and L2 are parallel to a vector B. So this is the vector. Let's consider that this is the vector B to which L2 and L1 are parallel. Clear? Now let angle between vector B and vector ST is theta. Then vector B cross vector ST is equal to magnitude of vector B, magnitude of vector ST, sin theta n cap. And if we take modulus on both the sides, then we will get magnitude of vector B cross vector ST is equal to magnitude of vector B into magnitude of vector ST sin theta into magnitude of n cap. Clear? And magnitude of unit vector n cap will be 1. So we will get magnitude of vector B cross vector ST is equal to magnitude of vector B into magnitude of vector ST sin theta. Clear? Now distance between two parallel lines L1 and L2 is the perpendicular distance between L1 and L2. So let us draw perpendicular. Okay, this is PT. Then PT is perpendicular to both L1 and L2. And angle between vector B and vector ST is theta. It means this angle is theta. So in triangle SPT T sin theta is equal to perpendicular PT upon ST. It means PT is equal to ST sin theta, and ST is the magnitude of vector ST. It means if we consider that PT is equal to D, then D is equal to magnitude of vector ST sin theta. Clear? So we can replace magnitude of vector ST sin theta by D. So now we will get magnitude of vector B cross vector ST is equal to magnitude of vector B into D, which implies that D is equal to magnitude of vector B cross vector ST upon magnitude of vector B, and this will give D is equal to magnitude of vector B cross vector ST upon magnitude of vector P. Clear? So this is the formula for distance between two parallel lines. D is equal to magnitude of vector B cross vector ST upon magnitude of vector B, and in place of vector ST we can write A2 minus A1, vector A2 minus vector A1. So it will give D is equal to magnitude of vector B cross vector A2 minus vector A1 upon magnitude of vector B. Clear? So if we know the values of vector A1, vector A2, vector B, then we can find the distance between two parallel lines, where vector B is the vector parallel to the lines L1 and L2, and vector A1 is the position vector of a point through which line L1 is passing, and vector A2 is the position vector of a point through which line L2 is passing. Now let's solve some questions. The question is find the shortest distance between the following pairs of parallel lines, whose equations are: first equation is vector r is equal to I cap plus 2j cap plus 3k cap plus lambda times of I cap minus j cap plus k cap, and vector r is equal to 2I cap minus j cap minus k cap plus mu times of minus I cap plus j cap minus k cap. So here we are given two lines in vector form. The first line is given by vector r is equal to I cap plus 2j cap plus 3k cap plus lambda times of I cap minus j cap plus k cap, and second line is given by vector r is equal to 2I cap minus j cap minus k cap plus mu times of minus I cap plus j cap minus k cap. So this will be vector A1 and this is vector B, and in the second line if we take minus sign common, then we will get mu into minus 1 times I cap minus j cap plus k cap. So this is also vector B. It represents vector B, and this is our vector A2. So now we have the values of vector A1, vector A2, vector B. So the shortest distance between these two lines L1 and L2 is given by D is equal to magnitude of vector B cross vector A2 minus vector A1 upon magnitude of vector B. Now first we have to find the value of vector A2 minus A1. So vector A2 minus vector A1 is equal to 2i minus I cap minus j minus 2j minus 3j cap minus k minus 3k minus 4k cap, and vector B is equal to I cap minus j cap plus k cap. Now we have to find the cross product of vector B and vector A2 minus vector A1, and this will give I cap, j cap, k cap. Now coefficient of vector B is 1, minus 1, 1, and coefficient of vector A2 minus vector A1 is 1, minus 3, minus 4. So this will give 4 plus 3. Minus 1 into minus 4 plus 4 minus minus 3, 7 I cap minus 1 into minus 4 minus minus 3, 7 I cap plus 1 into 1 minus minus 4, it means 5 j cap plus minus 3 plus 1, 2 j cap. Clear? And we also need magnitude of vector B. Magnitude of vector B is given by square root of 1 square plus minus 1 square plus 1 square. It means square root of 3. We also need the magnitude of vector B cross A2 minus vector A1, and that will be given by magnitude of vector B cross vector A2 minus vector A1 is equal to square root of 7 square plus 5 square plus 2 square, which is equal to 49 plus 25 plus 4, and this will give square root of 78. So putting these values in this equation, now we will get D is equal to square root of 78. Here will be modulus of vector B cross vector A2 minus vector A2. So we will get modulus of vector 78 upon root 3, and this can be written as square root of 78 upon 3. It means 3 to the 6, 3 6 are 18, square root of 26. So D is equal to square root of 26 units. This is the distance between the given two parallel lines. Now let's solve one more question. Now the second question is, the first line is given by, in the second question, first line is given by x minus 1 upon 2, y is equal to y minus 1 upon minus 1 is equal to z minus 0 upon 1. And second line is given by x minus 2 upon 4 is equal to y minus 1 upon minus 2 is equal to z plus 1 upon 2. Clear? So here, if we multiply the whole equation in the denominator of line L2 by 2, then the DRs of line L1 and L2 will become same. It means the line L1 is parallel to line L2. Say, if we write L1 in this form, x minus 1 upon 2 is equal to y minus 1 upon minus 1 is equal to z minus 0 upon 1 is equal to lambda, say, and second line is L2, x minus 2 upon 4 is equal to y minus 1 upon minus 2 is equal to z plus 1 upon 2. Line L2 can also be written as, say, this is equal to mu. So if we multiply the whole equation by 2, this can be written as x minus 2 upon 2 is equal to y minus 1 upon minus 1 and z plus 1 upon 1. Clear? If we take 2 common in the denominator and send it with mu, then it will change into this form. Clear? Now we can see that the direction ratios of line L1 and line L2 are same. So we can say that line L1 is parallel to line L2. Now we have to find the shortest distance between these two lines. So first we can change these lines into vector form. In vector form, the first line will become vector r is equal to x1 is equal to 1, y1 is equal to 1, z1 is equal to 0. So it will give I cap plus j cap plus 0 k cap plus lambda times of, this is a1, this is b1, this is c1. So this will give plus lambda times of 2 I cap minus j cap plus k cap, and second line in vector form will be vector r is equal to 2 I cap plus j cap minus k cap plus 2 into mu 2 I cap minus j cap plus k cap, because direction ratios of L1 and L2 are same, so we will get the same value. This is vector B, this is vector a1, and this is vector a2. So vector a2 minus a1 in this case is equal to 2i minus I cap, j minus j, 0 j cap, minus k minus 0 minus k cap. Vector B is 2i cap minus j cap plus k cap. Now we find vector B cross vector a2 minus vector a1, then we will get I cap, j cap, k cap. In the first row, scalar components of vector B, 2, minus 1, 1. In the second row, scalar components of vector a2 minus vector a1, 1, 0, minus 1. Simplifying this, we will get minus 1 into minus 1, 1, I cap. With j cap, we will get 1 into 1, minus, minus plus, 2 into 1. It means 3 j cap. And with k cap, we will get 2 into 0, 0, minus, minus plus, 1 k cap. Clear? Now, if we find the magnitude of vector B cross vector A2 minus vector A1, then this will give square root of 1 square plus b square plus 1 square. It means 9 plus 2 plus square root, it means square root of 11. And if we find the magnitude of vector B, the magnitude of vector B is given by 2 square plus minus 1 square plus 1 square, and which will give 4 plus 1 plus 1, which is equal to square root of 6. So now we put these values in the distance formula for distance between two parallel lines, then it will give d is equal to magnitude of vector B cross vector A2 minus vector A1, which is equal to root 11, and magnitude of upon in the denominator magnitude of vector B, which is equal to square root of 6. So the final value is square root of 11 upon square root of 6 units. So this is the required distance between the given two parallel lines. So if you have to find the distance between two parallel lines, you just have to identify the values of vector A1, vector A2 and vector B. Just calculate the values and put the values in the given formula and you will get the result. Now note down the homework. These are 3 questions based on distance between two parallel lines. To solve these questions, thank you so much.